Hello and welcome to our latest webinar on the topic of road maintenance. I'm really proud to announce my co-host for today, or more likely the presenter, since he will be doing most of the talking. It's our partner from Switzerland, Roland Christian. And Roland has been a client of GIS Cloud for over 5 years now, I would say, working directly with me. And since last year, we actually signed a partnership agreement to bring our relationship to the next level. So Roland, a pleasure to have you here today. My name is Antonia Netolitsky. For those of you who don't know, I'm head of sales here in GIS Cloud, and Roland, as I already mentioned, our partner from InfraTrace in Switzerland. Roland, I would say, has over 36 years of project experience in industrial sector, and he's an independent consultant. And as an owner of InfraTrace, he's strongly involved in building material innovations and carbon recovery. So on top of the work that he's doing in road maintenance for local government, he's leading by example, I would say, and showing green innovations in industry. So I'm really proud of that as well. So to not delay any longer, I'm sure that all of you are excited to see what Roland has prepared for us. So before we go into it, let's quickly just go through the agenda. For the introduction, Roland will just give us a short introduction on his company and what it is that they do. And after that, we will go directly into the presentation and see how they are utilizing GIS Cloud. You know, us here, we always love to showcase everything live within the application, so Roland will do that as well. And of course, in the end, we will have time for your questions. So feel free to ask them as we go. You can write in your questions either in the chat or Q&A section that you have in your meeting details. We will cover them in the end. And like I said, the webinar will be recorded, so you will be able to revisit and maybe share with others. So if you're ready, Roland, can you tell us more about InfraTrace?
Okay, so I'm trying to share my screen.
Okay, let me just
So
switch.
that is the most popular GIS application worldwide, Google Maps. You see that? You have it on the screen too?
I'm actually not seeing your screen.
What do you see?
Let me switch. I actually still see my screen, so I'm not sure what others are seeing. Let me stop my screen share. Maybe that's the problem. Okay, now I see it. Okay,
yeah.
Perfect.
I got the message that the attendees can see the screen now.
Perfect.
You see it too?
Mm-hmm.
Okay, so that's the most popular GIS application worldwide, Google Maps. I only show it to show you my location in Switzerland. That's Switzerland here. We have France, we have Germany, we have Austria, we have Italy, we have the very popular Swiss Alps, and I'm located with my company here in this little town, Gießen. It's near the Lake of Thun, near to the Bernese Alps, and my application or my project that I would like to share with you will be here. It's in a very close to the Swiss Alps, and only one little aspect about GIS for me. I work since about 37 years in industrial projects as a self-employed company, 37 years. And I have seen all the phases of digitalization, and I guess GIS will be very, very popular in the near future, because you can see we have a lot of applications like weather reports. Weather reports are GIS applications, live GIS applications. That's one aspect. or huge mall owners, shopping mall owners, they use GIS for density of population to see where they want to put the shopping mall. So in very specific areas, we have GIS as a very, very valuable tool. So now we come to infrastructure. And this is a little bit as another story, because there are a lot of different people involved in infrastructure of a local community. And when we talk about infrastructure in a local community, we not only talk about roads, we talk about electricity, we talk about light, we talk about fresh water, wastewater, we talk about telecommunication. That's a huge amount of data involved in the infrastructure of a local community. So there's a lot of people involved in this data pool. And what I have observed the last 6 years, we have to find interfaces, we have to find ways how we can exchange the data. How we can exchange the data between engineers and InfraTrace, or between the local community and InfraTrace. And that is a bit a hard way. It's not very easy to collect the data, because we have different formats, we have different GIS systems and so on. But in the end, I see more and more willingness from other partners that they see the value what we can do with GIS in infrastructure, because we can save a lot of money. Really a huge amount of money when we have infrastructure in administration, and when we can make the planning, the maintenance planning, and to get the life cycle of every aspect under control. Because every object in the infrastructure has a specific life cycle, and we have to get really close to this life cycle to see when the life end of this object, so we can maybe with some good maintenance extend the duration, the life cycle of this object. So that's the purpose to what we do now for roads. Why we do this? You can see here that was the order from the local community. They gave us only a few data about what we have to do. They said, okay, we have around 70 kilometers of roads, and we need an overview about the conditions of these roads. So that was actually the order. And then we have put this this road net into the local community. That's the border of the local community as a starting point to see how we have to organize then the collection. 70 kilometers, that means around a week or a little bit more of work in the place to collect, to catch the data, to get enough information to make a condition assignment. So that's the net view which we are seeing now here. And when we go to the table view of this net view, let's see, then we see here, just a second, the data which we have filled in. There's about 209 different sections which we made. We split a road. Let's say we have a road with about 5 kilometers. We don't assign the full 5 kilometers. We go and then we see that we have maybe 4, 5, 6 sections. So you can see we made about 209 sections. And we have then inside every section, we have the length, we have the width, we have the square meters, we have how the surface is. We have some notes which we put in. Then we have, for every section, we have made a video. I will show you that later. And the condition, that's the condition here. We have a condition, how will I say that, a shortcut for conditions, where then shows in the overview what is the general condition of this road net. So the next part is then to go into the field and to make these collections. But before I show you how we do that, I would like very short make a little journey with you inside the, just a second, inside what a road can stress. You can see this picture?
Yes.
Okay, it's not very complicated. A road has different stress factors. Mostly of them are weather stress factors. And one is the axis pressure, huge, big buses and so forth. But for the asphalt, for the bitumen, the material which holds the aggregates, the minerals, the stones together, is sunlight is a very, very heavy stress. Sunlight can be visible or in UV rays. And we know today that when you are higher, let's say in this local community, we are above 1,000 meters above sea level, we get a lot of UV rays into the surface of the road. So
definitely
that's
a lot of factors that you need to take into consideration, right?
Absolutely. And then the heat in summer. Heat vaporizes the oil inside the asphalt, so we have to see where we are, how much heat, how much light, how much colder temperature do we have. That is another aspect. Frost, defrost, because when we have water inside this body and we get a frost defrost period, where let's say during the day in winter we have enough temperature that it begins to defrost, and in the night it begins to frost again. We have ice and then we have defrost. All these changes stresses the body of the road very, very, very much. And maybe we have some groundwater which can go up and kill and make pressure from down up to the road, and snow and water, etc. So you can see we have common usual stress factors for a road. And the next picture which I would like to share with you is a little bit technical, but I like it to show it because we see in detail. We have the stones, we have the bitumen, that's a glue which glues the stones, and when we get water between the stones, this glue effect will weaken, and then we get cracks. That's the reason why we have cracks in roads, when the stone and the bitumen are not really fixed together. So that's the most important thing to know, that after a specific time, let's say about 3 to 5 years, a new asphalt begins to crack, because we have the pressure, we have weak points, we have water, we have all these factors. So that is the know-how which we have when we go inside such a project. And when we have visited all these sections, we get, I'll show you now the conditions. We get this picture. So we get several colors, and I guess it is very clear that the green ones are the good ones, the orange ones are a bit shaky, and the red ones, they have to do something immediately because there are a lot of damages accumulate.
Of course, this condition and this state that the roads are currently in were done directly going out in the field and taking certain measures. I presume we will show it just shortly.
So how we get this data? So I show you shortly how we do this. I hope it will work with a little video. Do you see this?
Yes.
Okay, we have a GoPro. We have a GoPro, and then we go over this. I have to communicate to the traffic behind me that I drive very slow. I drive between 15 to 20 kilometers per hour. That's very slow, so they don't like it when so they know, that's something technical going on. And what we do then, we drive all these sections and get the information about these sections. And we can see which kind of damages we have to note. You can see that's the overview of these damages. I guess then I go ahead. Inside the car, I have the GIS Cloud map. And inside the car, I have the tablet where I control the GoPro. And that is interesting to see what I have mentioned before, that are interfaces. That's me. That's me. And I am in communication with the local community. I'm in communication with the engineer. And I'm also in communication with the companies which have to maintain or fix the road. So we are a kind of a platform where we give services to all these different partners. And that was a missing point in the past. It's very important to know in Switzerland, there's a missing point. We have the engineers, but they are not so specialized in this kind of collection. Or they do for 10 years a collection on a paper map and fill a lot of papers, and they have no dynamic digital basics for planning. So we are really in a in a gap between all these different players, and what we we give the service to all this. I guess that is this also, maybe this one too. Sometimes we have to make some pictures, like here, or we go by feet with the GIS mobile, make some pictures. This in case this is a handmade video. That's the video camera here with this little tool. So for short sections or very special sections, and when I will film cows, then I do that by this tool. So okay, that is actually what we are doing. The rest is will I show you then live. Okay, that is, we get a lot of video data. We have in this case about 120 gigabyte of video data, which we can
a lot of raw materials that you need to then process.
Right, but it is very elegant, because then in the office I can do this. I show you now a film from this GoPro, and I have a special player where I can speed up or slow down. It's made like picture by picture. So when I see something very strange, what is this? And then I go a bit backwards, and so forth. So I have a lot of control functions where I can then collect the data and make an assignment and say, okay, this road has a lot of cracks, this road had this and that, and this, the total of these observations gives me then the color that I say, okay, it is orange or it is red. So that's the first stage. We get the raw material, and then we make an assignment. And when I go by feet or from the video estimation, I get the details. What means that? We collect some details where we are not so sure what we have to decide, because we have to find the sources, or what causes that problem, what causes the damages. And by car, usually you cannot find it out. You have to stay on the road. You have to smell. It sounds a little bit strange, but you have to smell the asphalt. You have to touch the asphalt. You have to see the environment. Is it in a forest part? Is it near a creek? Is it near whatever? You have to get really the full concept of this section to get an idea what could be the stress for this section. So then I go by feet and check what's going on. And then when I make some pictures, I make this assignment here. So I made one example. Let's see where it is. Okay, yeah, that is this one. We go into table view, and I show you now an example. So there I have some pictures made. This is a special kind of crack. I guess it's a crack from frost defrost. And the frost defrost weakens that area here, and when axis pressure comes onto this part during this period of frost defrost, you get this kind of cracks, because every crack has its own profile. And here we can see that from the cracks the substance begins to deteriorate, to go away,
Yep.
right? And then you have potholes. That's the next stage of the cracks. You get potholes. So we have to see how was the way, why this came, what can we do as a handling, as a recommendation then for the local community, how they have to fix it in the future. I guess there are these two pictures. Yeah, right. This is another kind of crack.
How did that happen?
Pardon?
How did this crack happen?
This is in the middle of the road.
Mm-hmm.
So you have to see normally in local communities, when they build a road, they build it in two different parts. You have the road, mm-hmm. and then you begin in a half. You lay down the asphalt in the half part, and then next phase lay down the asphalt in the second part, and then you get two bodies, two asphalt bodies, and the middle of these asphalt bodies is weak. That's a problem. And when you get some temperature tension, some tensions in any kind, this goes a little bit, they begins to move. And this is a typical move crack from two parts. You can see that in most or less in 90% of every road. On highways, you have the huge laying machines where they can lay 12 meters in full in one shot. Then you don't have this problem. Normally, when you have to make sections on the road, you get this. So that is another important information where we can say, okay, that is easy to fix. You have some liquid bitumen, and you can bring it down and fix it, so that it will be close for water, because water is the enemy for such a thing. When the water goes inside that and begins to freeze, and then it begins to expand, and ice expands and kills then the structure. So that is not a big deal to do. But anyhow, we have then all these different assignments, detail assignments with pictures, with notes, when we have did it, and the kind of damage. So we can filter. We have several shortcuts, mm-hmm. and I show you now what I will show you, this one. And now we can only see damages on the full body. It's only the damages on the full body. So we have to discuss with the local communities how they have to handle the full body. That's a serious aspect, because full body means the whole body is weak. Mm. And maybe they have really to replace.
Yeah, biggest priority to
right.
To
they have basically maybe to replace the first layer, or they have replaced several layers, because we have several layers where sometimes are weakened from whatever. And so we can really specifically give the local community some advices where they have to start. What are the priorities? So the next, what I would like to show you after this is we need additional data. So we have the condition of the road, we have some details, But as next, we have to see how the water in this local community is going on by nature. Because by nature means, where do we have sources of water, creeks, and so forth. And here I show you now, in the first place, I turn that off. What we see now here are all the objects which should control the water. These are mostly shafts or conduit. You know what a conduit is? Mm-hmm. Or conduits which should pull the water away from the roads. That's the purpose of this infrastructure aspect. So we need this data to see, is a road, is it enough done to save the road from water, or do we need some other installations? Let's say, for example, this one here, this road here is red. On the other side, we have a lot of shafts. But then we have to see, are the shafts at the right position? And as next, we have to turn on the, well, let's see where I have it. Second. All the information about the water. That takes a little bit of time. That's a WMS service from the canton, from the government, where we can see. That means it starts here, the water, and goes down and get collected and goes into a creek. And these are not creeks. This water is below.
Underground.
It's an underground water. That is very important to see, because especially on this part here, we see that a lot of water goes below the road and maybe is below and begins to pressure in winter with frost. That is important to see. Maybe we have to change the installations, the water control installations here, and to make it better. That is another indicator. And when I zoom out a little bit, we can see we have several parts. That is one part. Here is another part where we have water and damages. And when I go, no, not this, sorry. When I go a little bit inside the valley here, there's a really nice valley. It was a pleasure to do this work because it's an incredible, beautiful environment there.
I can imagine, yeah.
Absolutely, absolutely wonderful. Blue sky and green and cows and silence and peace. And there's really, sometimes I think it is a great job. It's a great chance to go into these places and to make this work. You can see here we have another weak point with some water there. And they have a lot of water. They have a lot of water there in this local community. And that goes now for me to the next aspect where I like to do it in 3D. You can see why I mentioned this.
Okay, that's really putting things into perspective.
I show you now what we are also now can show the local community in 3D. I turn off this one here, and I turn on the aerial pictures from Swiss Top or from the government. The government makes some photos by airplane, and they are quite precise, so we can use it. And so I have to show you this in this view here, and I turn off the this one too. So we have only the sections again, huh? And that is really, this is interesting, fascinating to see what's going on, because when we have the sun way, the sun goes up here and goes down here. It makes this way here. And in winter time, when the sun comes up, this part is in a shadow, it's cold. This part has only for maybe 2 hours some sun on this side. So we have a very, very frozen part. And on this side, we have a lot of sun because the sun begins to shine, let's say in the wintertime, 9 o'clock, 8:30, 9 o'clock, and we have the whole day, we have sun on this side. But on this side, we have a lot of shadow places where it is much colder, and only for 2 hours over the mid of the day, we get for 2 hours, we get of sun, and that defrosts these parts very quickly and then frost again. That is the dangerous part. So with 3D, we can show the local community such relations, such things which comes together, the weather aspect, sun, and the condition of the infrastructure.
And that's definitely the true beauty of GIS, when you have that kind of immediate results that you can read through by just viewing the map. So that's amazing. And especially when you are delivering that kind of information to a local community, to people who are not that well experienced and knowledgeable in the matter, it's really easy for them to understand the true problem and the real issue behind all of it.
The relations between these different factors, because the people which are responsible for the roads in the local communities, they are from there. They know their environment very good, but they don't know the relations between these different physical factors. And when I can show them that in 3D, that is really much, much more impressive than to show it only in this view. That is very important to see.
Yeah,
that makes a huge difference to show them the relations. Okay, that is the 3D aspect with the water. And now we go into planning, into calculations and so on. And I show you now an example. I have on, let's see where I have put it down. That's this one. And I have, this one here. I will show you it's a project pilot which we are doing. When I go to the section number on the 85, just a second. Down. We made a dashboard link. What means that? We would like to start with more connections between data, and one aspect which we could use is OneDrive. Microsoft OneDrive. I have the same data which I have in the map. I have now as a list, and we discuss with our customers how they can enrich some information out from GIS Cloud inside cloud-based basics like this one. This is a very simple table. We can use it for any kind of nodes. Let's say when they have the maintenance part and when they make some construction details and so on, they can put it inside GIS Cloud or they can put it in an external document. So they are free to connect a GIS Cloud with much more online cloud-based services. That is the purpose for this.
They are not locked. It's a great aspect to have that kind of communication in between different beneficial solutions are there.
Right. Another possibility is to online, it's also on OneDrive, online, to lay down an Excel sheet. This for another local community, this Excel sheet where we have the roads and all this information with the condition. And so they can start with planning. I guess that's not their own planning. That's my proposition, which I make. So it's not a lot of, I made only a demo to show them how they can handle it. And that's the possibilities, which kind of maintenance they do, the amount of money which they have to put in, and so forth. So they can, with the data from the GIS Cloud, then can make a 10-year planning or a 15-year planning or whatever with the priorities. So that's other kind of connection between a GIS Cloud and external cloud sources. And what I have also is the Power BI connection. That is let's see here. I have a little bit switch between the layers. Zustandsdetails. Okay, that is number 244. That's an online connection to Power BI data. What I did, I exported CSV data from GIS Cloud and have a live connection now in Power BI. And with Power BI, you can do a lot of things. It's a bit dangerous. You play around and you get some. It's fun. It's a lot of fun. So you have to reduce your enthusiasm and to bring it down to a really pragmatical way where you don't overwhelm the local community with a lot of figures and dashboard details and so on. As only the most important things is the road list, the general overview of the damage. So you can see, for example, we have 45 kilometers of orange, we have 9.8 kilometers of red, and we have 8.1 kilometers of green in percentage and so forth. And I did for them another aspect that is important, the wide. A lot of roads of the 70 kilometers are very small. And when I narrow it here and say, okay, I will only the roads between 2 and 4 meters, then I get the exact data of this wide. Why is this important? When they want to do a maintenance, when they want to do some construction aspects which have a duration of several days, they have to close the road. And some roads goes to parts where maybe 10, 12 families lives. So you have to organize.
Quite remote areas.
Right. What you do when you have a closed part of the road, they cannot go to another road. That's the only way how they can come down to the village. So that is a planning factor where they can show how they can handle this task.
Coordinate entire operations, right?
Right.
You need to coordinate with the community, with the people who are living there. You need to coordinate with the workers and the whole machinery that goes into it. Of course, the width of the road is also important for what kind of industrial vehicles are you bringing into the site as well, because some are maybe too big to go to that kind of narrow road.
Right. As you can see, the Power BI makes a live adjustment. So I have now narrowed between 3 and 3.5 meters, and I see only the roads between 3 and 3.5 meters. So they have the list and they can see, oh, on this road here, oh, that will be a problem because they have there some whatever. It is a part of information where they really can use for planning. That's the most important thing. Okay, that's the link to another cloud-based service with Power BI. I can recommend it. It's an incredible nice tool, but you have to be careful with playing with and to reduce it to the most important aspect. Otherwise, you can play around and that is fascinating, but not overwhelming the local community, because the in my case, the common people which I speak with, they are not so digital, they have not on a high affinity on digital aspects. So I have to be careful with. The last thing that I would like to show is what happens when a local community begins to adopt the benefit of GIS Cloud. That is it. That was a very, very, very interesting stage which I observed from local community. There's
before you show that, maybe I just wanted to point out that all of the things that you are seeing now from Roland that he is showing you guys, this data table and information that is being pulled in is designed by him through custom survey. He's using our mobile app to actually utilize and prepare for optimal field work as well with the mobile application that we have, right? So everything that was not delivered and brought into in regards to the data itself, but the data that Roland actually generated was actually prepared and done within GIS Cloud, right? Okay, carry on. Thank you.
Okay, now we see another local community. It's also in the Bernese Alps. I show you that here. It is here. We was here, and now we go to the very nice Simmental, the valley of Simmental, up to the Lenk. Lenk is a popular tourist place where you can skiing and hiking and biking and so on. It's very close to the higher Alps part here. And Lenk is my oldest customer for GIS Cloud. And they have now their own, they adopted GIS Cloud for their own purposes. So what they did, they started with hiking ways. They started with snow. What is the English word for that? When you shift away the snow from the roads?
Snow plows. Yeah.
Yeah. To organize the snow aspect, because you get a lot of snow sometimes, a meter or so. So you have to clean. You have to know what you do when you have to clean the roads for this. And then they have their own. What is that in English? That's the ownership of the local community. There are houses and every kind of construction, maybe for fresh water, etc. And they made a lot of own things, like signs, like signals, like containers for waste, like containers for dark waste, and so on. And they also made their own icons. So that was really nice for me to see. They have fully adopted the value of GIS Cloud as a very easy tool, as a very handy tool with mobile, with the desktop solution. So that is for me the way how it will go. I have another customer in another part of Switzerland which comes close to this, which we can generate a fascination for him, that I see the benefit, and that he begins by his own to start with GIS collection and several layer themes and so forth.
They basically started with road maintenance and infrastructure visibility, and then continued with mapping out the entire infrastructure and assets that they are managing as a community.
Yeah, because every sign, let's say, when we only see the signs which they have, as an example, that's also that all signs,
the condition, whether it needs to be replaced or is it properly marked, the condition of it.
It can from the sun it can go into a bright, that the color goes out and you cannot read it good enough and so on. That's an investment. That's money. And then you have 200-300 of these signs. That's accumulated. That's a huge of money, which you have to care. So that is my my way where I go with GIS. I guess I have told everything. I have only one little aspect, but maybe it's too late now. I will not overstress it, because we have the subject of accuracy. We work sometimes with an accuracy of 2 centimeters in the field.
I think that it's a good point to mention. I think that we have time for something like that.
You mean it's okay when I?
Yeah, you can.
I do not overstress it.
No, it's okay. I think you wanted to. You mentioned the possibility of pairing up your MDC or GIS Cloud MDC mobile app with external GPS device for better accuracy, right? Right.
So when we go in the common accuracy is about 5 meters, 4 to 5 meters, and that's not good enough for some specific aspects. Let's say, for example, when you have some wastewater or drinking water installations, you need more precise position. And I can connect the GIS mobile app. I show you that a little bit faster. You can see 4 or 5 centimeters. It depends a little, 3 centimeters. So that's live. That's live. 3 centimeters.
I mean, when you are mapping out that kind of information, that kind of precision is really a must-have to make appropriate planning and everything else. So,
even in forest situations, normally forest situations can be really, really tricky for satellite measurement. And I get between 12 and 40 centimeters inside a forest.
Yeah.
And let's say,
yeah,
pardon?
I wanted to say that the GPS that is accessible in our mobile app, it's basically a GPS that you are having on your mobile device. So depending on the device model that you are using, the GPS can fluctuate. Maybe it has a better unit inside of the mobile or lesser one. And on top of that, it depends on the area where you are, depends on the satellites and everything else. So possibility and option that we enable our users is to basically use the Bluetooth to connect to external GPS enhancer devices, which will enable that kind of precision then in that kind of situations.
So when somebody is interested in this kind of hardware, I can give them then the details, what kind of satellite receiver we use. It's a very, very clever concept, which we can use, and cheap. That's Perfect. Most important, because normally this high precision receivers, they cost a lot of money. Anyhow, that is another aspect which I like to play with around a little bit, to see the accuracy and to see how the mobile app works in a very high range of precision. So that is a very typical Swiss aspect to have this as a fun part.
I mean, all of us should strive for that, I would say so.
Okay. And the last thing is how we can bring GIS together with QGIS, for example, or another GIS system as a live connection between layers. That's the WFST service. It is what is the word for that? WFST, web function service transactional. OGC web function service transactional, and it works absolutely fine when you have your mobile. I can show you short this last thing when I wanted it. No, I don't have it here. But anyhow, that is fascinating to see when I have my mobile, and I can bring the data from my mobile onto GIS Cloud and directly live to QGIS. And in QGIS, I make some correction, and it makes tuck, 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 and goes back, and I see it then in my mobile. So that's a communication between different aspects of GIS processes. So it works too. But this web function service transaction is not very popular or common today in Switzerland. So we have to wait a little bit until the acceptance grows up.
Yeah, definitely. In GIS Cloud, what we see that we are possibly lacking or missing, then we try to accommodate and integrate with other solutions to get that kind of possibility open to them. But again, we want to avoid that kind of manual labor of bringing back and forward the data. So everything is much easier when you have that kind of live connection, because the main idea is to have live connections, live data feed, and see what's actually happening so you can react and respond faster. So a lot of services available for that kind of integration, I would say, with other, I would say, desktop GIS solutions out there. And like you said, we also have WMS if you only need to share read-only, or WFS for editable possibilities and capabilities. And the great thing, like you said, is that they are communicating in between each other. So whatever you do in QGIS then goes back immediately to GIS Cloud, so you can actually see what's going on. And that is really important when you have, and you are working with a larger number of users. Maybe you are not one-man job, you have like 10 or 20 or 30 people out in the field, and you need to quickly make certain changes that they are able to see out there while they are conducting certain field work. So that's really great and comes in handy. Okay.
I have two questions
Mm-hmm.
coming in from Greg and Christopher.
Yeah.
And they want to know which kind of GPS receiver I use. That's okay. That's okay. So that is I have started with several receivers, and now that is a receiver from Trimble called Catalyst. Catalyst Trimble is a very small unit, and the full smart part is in the cloud. So you get from Trimble a kind of it's an abonnement. No, it's what is the English word for that? You book some time. You can book some time, let's say 10 hours. And then you have per hour, I have a price of about 10 Swiss francs per hour. And the receiver is about, in Switzerland, about 400 Swiss francs with the precision of 1 to 2 centimeters. So that is a really, really fair, fine, good deal from Trimble to offer this when you don't need it for every day, and when you need it only maybe several hours a month or so. You can book that time, and then you get the time, and you can measure and so on. Trimble Catalyst is the product.
Perfect. In addition to that, we also have a list that we are generating from our other users who are making that kind of connection with external units. So we are updating that list on our manual page. We have like how to connect to external GPS unit, and then we have the provided list for which we are comfortable to confirm that it is pairable and it's working, because there are a lot of GPS units out there and different solutions, and maybe there are certain restrictions that they don't allow to have that kind of connection. So we rely on our user base and our customers to provide a feedback when something is working. So we just update the list so you can review that as well. So yeah, as I think that we are comfortable to say that we are now open for Q&A section. So please feel free to continue with your questions, and we will go through them as we can. So Roland, another question for you. Are you mapping cracks and roads damage while driving and photographing the roads at the same time, or is it that done in post in GIS Cloud?
It depends. When I'm on the road and driving and make my videos, and I come to a point where I see, oops, that's a bit complicated, it will not save it only by video, then I stop it, and then I go by feet and make my pictures. Or I can do a lot of estimations in the video. Let's say when I'm there several days, maybe I make, when I come back in the office and I show the videos which I did, and I say, oh, there I have to go another time. I have a second time to visit this place there because I'm not so sure. Then I have made a list of notes of places where I have to revisit then the second time. And then I go by feet and make my pictures and get more data about the situation. And the next,
basically it's a combination of both, right? Depending on the condition and the issue that you
and the situation and the complexity, and as I mentioned before, maybe I have to smell a little bit the environment. Yeah, that's true. That's really true, because when you smell some water and it smells, it smells different. The road can smell. I promise you, it's true. It smells.
Okay, different. Next question is, where are stored the video clips? Or in GIS Cloud or external? Where do you store your video clips?
For sure, external. I mean, the storage place for GIS data is too valuable for video data. So I have my server. I can show you that. You can see the link. Let's say I go back to my
I think that we are currently on my screen where I'm presenting like Q&A section, but you basically pasted the URL link that will guide then to the video.
Right. It's a common link. I have a server which is fast enough to play the videos, stream the videos, and today it's no problem. In the early days it was a bit tricky to start with really streaming, but today it's no problem. But you cannot put it onto YouTube. That will not work.
Yeah.
YouTube makes a kind of compression which kills every detail in the road.
I try that as well. It's really
no chance. No chance. So you have to make it pure.
One other way I do have GIS Cloud does have an option of uploading actual video clips in GIS Cloud, so you can actually have them stored within GIS Cloud and pull them directly from there. But of course, to save some storage space, it's always maybe better if you have alternative to store it somewhere and then paste it through URL in GIS Cloud, right?
Yeah. And imagine, Antonia, when I have 10 local communities and every local community has about 100, 120 gigabyte, we get in the terabyte section.
Definitely.
So I guess
much cheaper option to paste the links.
Absolutely.
And it's fully GIS Cloud supported, so why not?
So we have other question.
Hello, more of a comment than question on the Trimble system you mentioned. If you are using an iPad, the location still has the high accuracy from the Trimble, but the GPS accuracy that can be collected automatically from the MDC can only collect the value of 5 meters from the iPad.
That is an issue of the iPad. It had nothing to do with the accuracy. The iPad cannot go down to this precise actual accuracy. When I go onto an Android, the Android can do it. You get the accuracy in detail 2 centimeters, 3 centimeters, but you can measure with an iPad, and you get on the map, you get the correct accuracy then. It's a bit confusing, but it works. We have tested that, it works.
One question regarding smelling of the asphalt. Is there a scent field in your schema? So do you type in, I suppose?
What? I don't understand this question. What is the scent field?
I think it is like in your table where you have all the information for each condition. Then do you have a field where you write in what
smell,
what you smelled, how it smelled like?
No, that's only for me important, for the local community.
That's why you need to hire
they will get the idea. There's a little bit.
This is where his expertise comes to. You need to hire Roland to get that kind of precise.
Yeah, there's a specialist. He can smell the road. He can smell the damages. He's a real great guy. He can smell it.
Okay, on to the next question. Please tell me if the base map used in this solution with QGIS environment are sufficiently in accuracy and updating time. We have to use aerial photo with high resolution instead of satellite images. So it's basically about how old the data is.
So we have several base maps which we can use. The basic, I did not show that, I missed it. The basic base map which we use is the official cadastre information from the Swiss government. We have for every local community we have the parcels, the parts and the roads and ownership and everything really precise. And on top of this, I have from the Swiss government the aerial photo layer, which fits with the cadastre layer. So I have a very good, precise base map ground for my work. I'm not sure what kind of a base map do you have there, Nahim? With higher resolution instead of satellite images. I guess it will be similar to that what we use. But I have no idea what kind of base map do you have. We have on the other side in Switzerland, we have a lot, maybe 10, no, that's more. It's about 100,000
Is that open source data
points.
Or do you need to buy it? Is that open source data? Do you have like free access to it or do you need to buy
It's open source. We have in Switzerland a law started several years ago, open data, open GIS data. So we get all this data for free. And we have on the other side, we have, how will I say that, points. The whole Switzerland was measured, and you have these points in the ground, metallic plates, where they have with the old-fashioned engineering, geometrical precision. Hey, they made all this part, so you can adjust your GIS mobile app with this. Go on such a plate and say, okay, that's here. That's exactly measured, so I can start from here. We have in Switzerland this, but I don't know if in other countries they work
So
this sort of thing.
Yeah, we have a question related to this. What external service is this? Can you share info with us?
Right.
Like, do you have some sort of web source for accessing that kind of data? Or
so this question from Dragan: what external service is it? Can you share info with us? Which service is meant with that?
Let's wait for Dragan to maybe elaborate a little bit, and we can jump to question from Greg. You have been using biochar.
Yeah, biochar. Yeah. We are in a very special moment today. We have tests done with concrete. We have tests done with asphalt. We have tests done with bricks. And we are really close to the point where we can use a lot of biochar as a CO2 reduction into building. It's really close. We are in the middle of tests, and at Friday I make my first workshop in the Swiss school for construction specialists. I make a day-long workshop about this subject where we discuss, and I can show them the evidences, the technical aspects, and that will be a huge breakthrough for CO2 reduction when we can bring biochar into building construction materials. And
maybe for some attendees who don't know the term of biochar, can you tell us in a sentence what biochar is and long-term durability of InfraGreen?
We have the problem today that we have too much CO2 in the atmosphere, and one solution is to bring with negative emissions this CO2 aspect down. And the important part is what are sources, what are possible sources to bring the CO2 down. And one source is waste, organic waste. Organic waste can be from food, it can be from wastewater, it can be from wood. We do not burn fresh wood, we only burn and reduce waste from wood into carbon. And carbon is biochar. We have about 80 to 90% carbon inside the biochar. And when we sink down the biochar into concrete, into soil, into whatever, we reduce the CO2 mechanism, because oxygen cannot pull out this again and make some CO2. When it is fixed inside the block of concrete, it is done. For about several tens of years, nothing can happen with this carbon. It cannot turn into CO2 again. That's the trick of, and the mechanism or the technology calls pyrolysis. Pyrolysis means without oxygen, we bring down with high heat. How will I say that? We separate all the parts inside the organic material. We have gases for whatever energy and so on, and the rest is biochar. And this is a very valuable tool and way to handle CO2 reduction. And that is also on a map. It's maybe for another webinar.
Another webinar, yeah, special topic just for those green innovations that Ronald is quite passionate about. Of course, if you would like to discuss maybe on one-to-one basis, you have Roland's email here listed in my screen share currently. You can always reach out to him. You can schedule some sort of meet with him. I think that he would be happy to discuss it further. Back to Dragan and external service. It was actually related to video streaming.
To which medium?
For video, the videos that you are doing, the video streaming.
That's a normal server.
Not a YouTube, but it's a
normal. I have a server where I have hosted my website, and I have enough space there where I can put my videos on it via file transfer protocol, FTP, and then make the link to the GIS Cloud form, and then I have my video stream. And that works with every web server today.
One question from Fuad: are you considering using machine learning algorithm to analyze the image of payment conditions?
That is an interesting question. Since several years we discuss this aspect, and I guess 50% can be done by machine learning. But you have, as I mentioned, smelling. You get a full perception of what's going on this section of a road. I'm not sure if an algorithm can really pull out enough data from this, because the human senses are much more today, much more precise to get a full picture of it. But I guess it goes more and more in this way. Like when I do the videos, I made a shortcut. In the early days, we made only all things by feet. We walk all these 70 kilometers by feet and made pictures. And today we use video. So we made a little step in this direction.
Okay. And feedback from Naeem related to the imagery that they are using. He's saying that in Tunisia, we have to update with new acquisition, new imagery for all Tunisia with 50 centimeters. And for big cities, we need high resolution with 10 centimeters.
And what's the question?
That was just a follow-up, I think, to
okay.
We use aerial photo with high resolution instead of satellite.
Great. Okay.
Okay, so that I think brings us to all the questions that you had, and I think that we are running out of time as well. So please, guys, feel free to send any additional questions to Roland or to GIS Cloud. Roland will be happy to connect with you, especially if you are in Switzerland, if you have some sort of ideas or things that you would like to share or collaborate on. But of course, anybody else who would like to maybe pick his brain a little bit, or maybe start some sort of collaboration on biochar or anything else as well, I think that I speak for you, Roland, that you will be happy to make that kind of connection with our attendees, right?
Okay, thank you for your attention. It was nice to show you this.
It's been a pleasure, Roland. Thank you so much for your presentation and for your time, and to share with GIS Cloud community how it is that you are utilizing GIS Cloud, what kind of work do you do, and I think that you probably gave our attendees some ideas on how to improve their own processes, and definitely much valued from my end as well. So thank you so much.
You're welcome. And I wish you a very nice evening. And I have another question here. I have two questions. Let's see what is. Oh, no, okay. It was thank you.
It's just a thank you. Yeah, thank you as well for attending.
Okay.
Thank you guys as well. So yeah, in any case, reach out to us with any follow-up questions or things that you would like to discuss. We will be happy to address them.
Okay. Bye-bye.
Bye, guys. Take care.